Okay, so we've all played around with chatbots, right? But the game is seriously changing. We're moving way beyond simple question and answer bots and into a world of truly autonomous AI agents. Agents that can actually do complex jobs. Today, we're going to break down how you actually build one.
So let's start with the big problem. A large language model, an LLM, is kind of like this brilliant brain just floating in a jar. It's got incredible reasoning power for sure, but it's totally isolated. It can't do anything in the real world. It has no memory of your last conversation, and it definitely doesn't know a thing about your company's private files. So the question becomes, how do we give this brain a body?
Well, the answer is what we call an AI agent. And listen, this is way more than just a new buzzword. It's a really fundamental shift in thinking. We're not just asking an AI to answer a question anymore. We're giving it an actual job to do. Here's a great way to think about the difference. A normal call to an LLM. That's like hiring a freelance contractor for one specific task. You ask it to do something, it gives you a result, and that's it. Transaction over. But an AI agent? That's like hiring a full-time employee. It sticks around. It remembers the context of your work, it understands its role, and it has a whole set of tools to get its job done day after day.
So, this is the key takeaway. An agent isn't a new kind of model. It's a whole structure, a layer that you build on top of the LLM. And that structure is what gives our brain in a jar its autonomy. It's the framework that lets the model actually run code, remember things, and use tools. This is what turns a simple text generator into a genuinely capable coworker.
Okay, so to get our LLM from a brain to a functioning agent, we've got to equip it with the right stuff. You can think of it as giving it an essential toolkit. We're going to look at the three most critical components that give an agent all its power: the ability to act, the ability to remember, and the ability to access specific private knowledge. All right, first things first, we've got a thinking machine. We've established that. But thinking isn't really enough, is it? It needs to be able to do things. So how do we give this brain a set of hands to actually interact with the world around it? The answer is something called tools. And in the agent world, a tool is basically just a function that the agent can decide to call on its own. These are its hands. A tool could be something simple, like a calculator. Or it could be something much more powerful, like a function to query your internal database, search Google, or even connect to a third-party service like Stripe or Salesforce. There's a perfect real-world example of this. An investor, Alana Goyal, tried building a book recommendation agent. Her first attempt was a total flop. She just dumped a huge list of books into the agent. It had no idea what to do. The breakthrough only happened when she created very specific tools, like a tool to get books by genre. The lesson here is huge. You really have to think like an analyst. You have to break down your big problem into small, clear, reusable actions. That's how you set your agent up for success.
Okay, so our agent has hands. It can act. That's a huge step. But what about memory? A standard LLM basically has the memory of a goldfish. The second your chat window closes, poof, it's all gone. So how do we give our agent a real, persistent memory so it can actually have a normal, contextual conversation with you over time?
This quote from the author of our source material it's a perfect and hilarious example of what we call working memory. The agent is designed to store key facts about a user. Well, in his case, because his kids are always using his devices to talk to the AI, the agent has learned and stored in its memory that he is a 5-year-old girl who's really into Squishmallows. It's a funny little bug, but it perfectly shows how memory creates a persistent, ongoing profile of the user.
Now, if you peek under the hood, a lot of developers are using something called hierarchical memory. And it's a really smart system. See, you can't just feed the agent the entire history of every conversation. That would get super slow and incredibly expensive. So instead, it does two clever things at once. It always keeps the last few messages right there for immediate context, and at the same time, it does a quick search over its long-term memory to pull up any past details that are relevant to what you're talking about right now.
And that brings us to the last and maybe most important piece of our toolkit. Our agent can act and it can remember, but all of its knowledge comes from the public internet data it was trained on. How do we get it to know about your stuff? Your internal company wiki or the latest specs for a product that doesn't even exist yet?
The most popular solution by far is a technique called Retrieval-Augmented Generation, or RAG for short. The absolute easiest way to think about RAG is that you're giving the agent its own private, searchable library. So when you ask a question, the agent doesn't just guess. First, it goes and retrieves the most relevant documents from its special library, and then it uses that information to generate a much smarter, more accurate answer.
So what does this whole RAG thing look like in practice? Well, it's basically a 5-step process. First up is chunking. You take your big documents and you break them down into small, digestible pieces. Next is embedding, where those text chunks get turned into numbers, a format the AI can actually work with. Third, all those numerical versions get stored and indexed in a special kind of database. Now for the magic part. The user asks a question and the system runs a query to find the most relevant chunks. And finally, synthesis. The LLM takes those pieces it found and uses them to put together a complete, well-informed answer.
So we've got our core building blocks, right? We've got tools, memory, and knowledge from RAG. But just having the pieces isn't enough. How do you make them all work together? If you want your agent to be reliable and predictable, just letting it decide what to do every single time, that might not cut it. You need to give it a plan.
And that's where something called graph-based workflows come into play. Instead of leaving everything up to the agent's whim, you give it a structured blueprint to follow. A workflow like this is awesome because it lets an agent do multiple things at once, like, say, search the web and query a database in parallel, and then it can merge all that information together to create one final synthesized answer. This gives you way more control and way more predictable results.
And then, for the really, really complex problems, you can take it a step further into multi-agent systems. This is where, as the source material jokes, AI engineering starts to feel a lot like organizational design. You're literally building a team of specialized agents. You might have one agent that's the planner, another that's the coder, and a third that acts as the reviewer. They all collaborate, just like a human team would, to tackle jobs that would be way too big for any single agent.
So that was a super quick tour of how to build an AI agent. But it's really important to take a step back and remember the world we're building this in. The pace of change in AI right now is just wild. Some people are calling it the eternal September of AI, which is this idea that the ground is shifting so fast all the time that, in a way, we're all beginners here.
And that really brings us to this final thought from Sam Bhagwat. He says, in a field where the ground shifts constantly, we're all perpetual beginners. To build something enduring, you have to stay humble. I think that's such a powerful reminder. In a field that moves this fast, maybe the most important tool you can have is just a willingness to constantly be learning.
So we've walked through the whole toolkit, giving a language model tools so it can act, giving it memory so it can have real conversations, and giving it a private knowledge base so it knows about your world. We've even seen how to orchestrate all these pieces into powerful, capable systems. So I guess the final question really is for you. Now that you know the principles, what kind of agent would you build?